have. So this webinar is a partnership between NASA's Earth to Sky Idaho, which has the aim of connecting local educators with scientists. We also are funded through the Idaho STEM Action, a lab at University of Idaho and the city of Boise. So why did we put together all of these partnerships? What is it that we're trying to do with you all during these 4 talks? Well, we would like to engage you all in really connecting to scientists and finding a way to then connect that science to your site and your place. We want this to be applicable to you. We also want to facilitate an open space where you can connect with your colleagues, share ideas, learn new things together. And eventually we'd like to create an ever-growing community of interpreters, educators, and scientists sharing communication techniques. So that's why we've invited you here. Hopefully that's why you showed up. And for today's schedule, we are going to be speaking with David Hoekema, and I'll pass it on to him here soon. He's going to be talking about how we can create a more resilient Idaho in the face of water scarcity. He's going to talk about some of our history with water rights in Idaho, and then we're going to look forward into the future to maybe what that will look like as we go down the road. And we're going to have time for questions and answers. So again, an opportunity for you to talk about your questions and get them answered by an expert. So just some quick tech notes. We are recording today's session. You might notice that automatic closed captioning is on. You can go ahead and turn that off with the 3 dots that say more in the right-hand corner of your screen. And we are going to have points of discussion. We do encourage that. We also ask that you are muted when you're not speaking. And if you are available to have your camera on and you'd like to put some faces to names, we do encourage that as well. If you do come across any tech questions, you can ask me about it in the chat. So with that, I would love to turn it over to our speaker today. So David Hoekema, go ahead and take it away.
Well, I'm glad to be here and be a part of this conversation. I think climate change is a very important topic, and understanding water management and the way water resources are handled in the state is a really big matter when it comes to dealing with water, because Idaho is a water scarce state in the aspect that we don't have water when we need it the most, which is in the summertime. But as an overall picture of the state, we're water rich. It's just we get it in the winter when we theoretically don't need it, and we use it in the summer when we don't get precipitation. And so we'll talk about how the water is transferred from the winter into the summer use, and just kind of step through, and I'll start off with presenting my screen. Now it's here. So just a quick, everybody see the screen? Okay. So what we're looking at in this first slide is climate normals from 1900 to 2020. A climate normal represents the previous 30 years in a decadal format. So it jumps every decade, you get a new 30 years. And that's kind of the way we look back and say, well, that's our expectation of what the climate's going to be like. And historically, they did that because climate has always fluctuated over time with some variation up and down. Like the 1970s was pretty wet, the 1930s was fairly dry. And so in looking at this climate normal, it's the daily average temperature in the Middle Snake, which is our region here. The Middle Snake goes from King Hill down to, or I'll refer to in this presentation, Milner Dam down to Hell's Canyon. It includes the Boise River, the Payette River, the Hawaii, kind of our region right in here. And so if you look at these box plots and the distribution, right in the middle of the box plots, the median. And so it kind of, the climate normals fluctuated up and down. We have these three climate normals that included 1934, because they cross decades, 1934 shows up in all three of those climate normals. And that was the hottest year in the United States. Amazing year with drought all the way across the country, except up in Puget Sound and down at the tail end of Florida. But everything else was pretty much covered in drought. And so that kind of skews the extremes in that distribution. But then it just kind of bounces around until you get to the last three climate normals and you see the temperature going upward. And if you were to break down this last climate normal, 1991 to 2020, into its 3 decades, each decade the median's getting hotter. So this is a trend that's robust, and I'm not going to spend much time on that. I don't think that's the main focus of our presentation, but just, this is a way to look at how
that should work.
But when it gets to water management, I developed this little cartoon history of the Snake Plain Aquifer, just to give an idea of what's going on. So in Idaho, about 1/3 of our water use comes from the aquifer, and almost all of our drinking water comes from the aquifer. Various aquifers across the state. The biggest one is the Eastern Snake Plain Aquifer. But we have one here in the Boise Valley, and pretty much anywhere you're at, there's an aquifer under your feet, unless you're standing on bedrock. So if you dig down deep enough anywhere you're at, eventually, as you get down far enough, your hole will start to fill in with water. When my brother and I were little, we lived in Baton Rouge for 1 year. I have a twin brother who looks just like me. And we were digging a hole for put in a basketball hoop, and we got down a foot and our hole started filling in with water. So if you're by the beach and you're digging in the sand and that hole is filling in with water, that's actually the aquifer right there that you're tapped into. Now, in most places, the aquifer, especially in Idaho, is pretty deep. So you'd have to dig a hole, and we're digging one right now with the department. It's almost 1,000 feet deep before we hit water. And that takes a lot of energy to pull that water out of the ground. But in this case, that hole's just for monitoring the water table of the aquifer. So before European settlement, in 1905, it was the Snake Plain was kind of in a natural state for the most part. And we're looking at 1905 because we're considering mainly the area around Twin Falls. So pre-1905, most of the European settlement was just in the canyon. There was pretty much nothing above the canyon except the little town of Shoshone that was on the Oregon Short Line. And so you just had precipitation come only in the winter when that precipitation was great enough that it exceeded the sagebrush and grass water demand. Then you'll get some percolation by gravity. Just the water just kind of works its way down, and it works its way down through the soil until it hits a point where the soil is saturated. And that's where, if you're digging, your hole fills in with water. So you just had a little bit of that going on, natural recharge. It gets into the aquifer, and then once the water's in the aquifer, it's not just a lake underground that sits there, but it moves gradually towards some point of discharge. And over here we have a example of the Snake River incised down into the aquifer. And so at a natural state, the groundwater would gradually drift over to the canyon. It would come out of the canyon walls. And there's a number of state parks down in the Snake River Canyon where you can see these springs just gushing out of the walls of the canyon. And in its natural state, it was roughly 4,500 CFS. But then what happened is, after 1905, and we'll show a picture of the dam that was built, they diverted water out into the plain, and those canals lose a ton of water in distribution. There's one in particular, the Milner-Gooding Canal, that runs from Milner Dam up to the Big Wood River. It's about 70 miles, it crosses the desert. It's estimated to lose 75% of the water in conveying it to the farm. So 75% ends up as what we call incidental recharge to the aquifer. And so you have these very leaky canals adding a lot of water. Then in the early 1900s, they would just take the water out of the canal and they would flood the field, which provided way more water to the crops than they needed. And so a lot of that water would get below the root zone and then just work its way down into the aquifer. And so unfortunately, the colors don't show up very well, but if you look at this, the end of these arrows, this line, there's also a line here that shows the old aquifer level. So as all that recharge was occurring incidental to irrigation, the groundwater rose up to the level shown here now, and that increased the amount of water coming back into the Snake River to roughly around 6,600 CFS, or cubic feet per second, was how we typically measure water. And then after 1950, they developed groundwater pumping. And so they began to extract water out of the aquifer. They also began to do, the federal government funded a lot of water conservation measures. One of those is to line canals. Well, if you line canals, all of a sudden you're losing that water that's recharging the aquifer. And we'll see that this water down here is really valuable, that had been developed, and people had rights to it. And so as they began to lose that water, that created the whole controversy in Idaho over water rights with the Swan Falls controversy, the Snake River Basin adjudication. All of that is based on this aquifer being drawn back down. And so in addition to, lining canals, trying to conserve water that way, farmers began to run their pivots on their fields. And now with computerized technology, when a pivot circles a field, it can focus down into getting just enough water onto the field that meets the crop water need. And you can, really limit the amount of recharge coming from the field, the incidental recharge. And that allows the farmers to get a much higher yield. They make more money. They can also expand irrigation, especially in drought years. They're able to irrigate a lot more land than they would have otherwise. And then in addition, with the groundwater pumping it out, you've got less going in and more coming out. And so that's lowered the springs back almost to the level they were at prior to European settlement. And if we did nothing about it, that aquifer would continue to go down, to levels below what was there historically pre-settlement. And so that was the whole, and is probably the major water issue across the state currently. And with that, maybe we could, does anybody have any questions about this? Because this is the key concept going forward. Okay. If nobody has questions, we'll go forward a little bit and discuss some more points. So the next point I'd like to discuss is the hydrograph here, and my daughter's going to step in and help me. But this is a hydrograph off the Snake River. This is the flow. And so a hydrograph, you have the flow rate of the river, and this is the inflow into the reservoirs. So this is the flow rate. And then in orange, we have the water use for irrigation. And so on April, the water rights turn on. And then as it heats up, more and more crop water demand comes in. Also, more crops are planted later in the season until you hit your peak use pretty much from May until somewhere in August, and then it gradually tapers off. Well, with the water coming into the reservoirs, if there were no reservoirs, this is the water that would be usable. And you can see that all this water used here would not, you couldn't use any water in this section. There isn't water to meet that need. And so what happens is this water here at the top of the hydrograph above the orange, it's stored in the reservoirs as well as this water over here. It's all available for storage in the reservoir until the reservoir is full, at which point they spill it as flood control. So we store this in the water in the reservoirs, and then we can release it out of the reservoirs to meet this crop water demand at the end of the season. And that's the basic concept. So, when kids are up skiing on Bogus, like my kids love to do. They're standing on top of the biggest reservoir in the state. Because if you look at this hydrograph, this is just kind of the natural condition of the river, but this is the snow melt from where the hydrograph starts to rise to where it comes down. That's the snow reservoir being released out of the mountains. And prior to the development of dams, that was all that farmers could use. So we'll do a little illustration here with my daughter to kind of show how this works. So I've got a camera here. She's going to hold it for me. So if we're looking at the hydrograph, the first.
It might help if you stop your screen share, because right now.
Oh, yeah, I'll stop my screen share here. Thank you. So can you zoom in? Yeah, just zoom in. All right, bring it up just a little bit. Let's see if we can move it into position. So you got to move this way. Can you hold it up higher? And then this way. Okay, hold it right there. Okay. Can everybody see that? So we've got a hydrograph and now we have water rights. So the first people to come and settle had maybe like an 1870 right. These numbers are totally arbitrary. I just pulled them out of the air. And that water is always going to, whoever has that 1870 right in prior appropriation, they get that water no matter what until there's, but then the next person stacks on top. So the 1872 right, it's then the junior right. And if there's any water available after the 1870s filled, you can then fill the 1872. And then you have a bunch of people come in and they put in some more canals at an 1875. So that water right now stacks on top. When there's water available, they get theirs. And then we got the 1880 here, a whole bunch of more canals come in, their water rights stack on top. Then 1895, and finally, yeah, 1895 is our last. So then if we take our hydrograph, which I showed in the last one, and we put it on here, what you can see is prior to the dams, where this comes down in blue, that's all storage water. And before dams, they just got cut off. So the person with an 1895 gets cut off at the end of June, the beginning of July. The person with the 1880 gets cut off maybe mid-June, 1875, or mid-July, 1875, August. And so you're gradually cutting those rights down, but the 1870 never gets touched. Now, part of this underlying water here is aquifer water. So if we drain the aquifer, then all of a sudden we start cutting these rights earlier in the year. And that's where a lot of the water right controversy came in. Also, if we have a drought year, here's my drought hydrograph. You can see there's a whole lot more storage use needed. And that's what they designed the system for. They designed it to be able to meet in a drought year the amount of water available. So this year, we started off with a good reservoir system. We had a crazy drought, one like we've never seen before as far as the switch in climate to being really hot. And so we've now drained our reservoir system out. So if we get another back-to-back drought year, we'll be in trouble. So hopefully not. Hopefully we go back to a normal hydrograph and we can refill the reservoirs. Okay.
David, I love that visual. That's the most sense that water rights has ever made for me. I've noticed a few questions coming in about that. Brian wants to know if those rights get passed down to the property owner.
Typically they do, but they don't have to. We have what's called a water bank. So if you're a water user and you're using water on your land and maybe you get sick, maybe you're just not going to farm for a couple of years, you can put water into the water bank, your water right into the bank, and then somebody else can rent that from the bank and apply it somewhere else. And there's a whole process behind that. Also, if you want and you decide you're just done farming, but you want to keep the land, then that right can be bought out of the bank and transferred to some other place in the state. And that's a whole separate conversation. But yeah, so it typically comes with the land, but it doesn't have to. Yeah. Any other questions?
I see some questions in the chat from earlier when you were talking about the canals and lining those. Elizabeth was wondering how much water in the canals is lost to evaporation.
Very little, because when water's running, moving, it doesn't lose very much, because what you need for water to evaporate efficiently is you need the surface of the water to be relatively stable, and then you develop some a heat differential across that, and then it starts to evaporate. But when the water's tumbling and moving, you don't lose a lot of evaporation in the moving water. You do lose some, but it's insignificant compared to the amount that seeps down into the aquifer. It would probably be maybe on the order of 5% on a really, hot extreme. And I think that would be high. I would guess lower than that. But people have looked into it. I don't have the number offhand, but in really hot areas like Arizona, they'll cover a canal, but typically in Idaho, it's minimal compared to the other losses.
And then the last question that I see floating in the chat is from Brian. And I believe Brian was referencing, and Brian, feel free to pop into the chat with clarification. But Brian was asking if these were local or federal decisions, and that was in reference, I believe, to start pumping the groundwater.
All water rights are managed by the state. Even the federal water rights are controlled by the state. So all the groundwater rights were issued by the state. So yeah, it's all state operated.
So I guess, Jenny, I keep thinking as I look around to all the development around me, that as they put in all these housing developments and all these lawns, does that have an appreciable effect on the amount of water available?
Yeah, that is a huge topic, but the general understanding, and there's been quite a bit of research done into it, the general understanding is if you're converting farmland, typically what they're requiring now in most parts of the state is to use the canal system that's in place for irrigation. They didn't do that early in Boise, and so a lot of the areas that are down by the river have kind of a mix between people who irrigate out of the ditch and people who irrigate from the city. But generally, they're requiring people now in new development to irrigate from the ditch if they're within an irrigation district. If they're not, they're pumping from the aquifer. But if you're converting farmland into residential, you're using a lot less water because the surface area is now mostly hardened. And so you're only growing grass. It's a bit of a longer season, but generally the volume is quite a bit less, and people are more efficient sometimes with their lawn irrigation, especially if they're paying for it. There's some parts of the state where people don't have to pay for their lawn irrigation, and then of course you can use all the water you want, which we used to do that. I always told my wife it was our aquifer recharge program. My family has some very interesting household discussions. When I was growing up, my dad was a doctor, and so we'd always have very gross medical discussions that nobody else could understand. But at our house, we talk about our backyard aquifer recharge program when we're over irrigating. But So my kids get to see lots of dams and hear lots of hydrology.
What a great resource to have.
Yeah.
And that's all the questions I see floating around now. We'll definitely go back to answer some more though.
There's one more in there, Jenny, that
Oh.
just came in from Carrie. Are there any plans for cleaning or dredging the reservoirs like Black Canyon seems to be filling with sand?
Yeah, there's challenges behind that, cost wise, pollutants in the dredging. It's really outside of my field of expertise. But yeah, it's definitely an issue of a lot of sedimentation collecting, because the dams basically stop the flow of sediment down the river. But yeah, that's outside of my expertise, so I can't provide you much insight. So back to our hydrograph. Now we're past the water rights section here. And how do I move forward? Okay. So the next question, and this is one that surprises a lot of people, is how many snake rivers are there in Idaho? If you look at Idaho, the map over here, what's outlined in green represents the entire Snake River Basin to where it drains into the Columbia River. The Snake River Basin represents about a quarter of the tributary land to the Columbia River, but only a small fraction of its total volume of flow, because we're much drier than our basins to the north. But from a water management perspective, we actually consider the Snake River to be two rivers. And here's why. In 1905, can you see the whole screen here? Okay. In 1905, a guy named Perrine, he had a vision of, turning the whole area of Twin Falls, Jerome, that whole area into an agricultural land. Prior to that, it was just sagebrush desert. And so he, under the Carey Act, he acquired all the rights in the Snake River that were unallocated. He built this dam with help of a few other people named Buell and Kimberly. And the Twin Falls Canal Company diverts to the south. The North Side Canal Company, which irrigates the Jerome area, comes off to the north of the dam. And then this one over here, the Milner Gooding, it pulls water 70 miles across the desert up into the Big Wood River and Little Wood River, where it's then used up there, all the way out to Gooding. And this is the super leaky canal that we like to use for recharge in the wintertime. But you'll notice this is the Snake River. And you can walk across it and your feet will stay nice and dry. This picture is taken off Google Earth, but the state water plan has a minimum stream flow at Milner Dam, and that minimum stream flow is 0. And that's the state's target. That's what we want. And in the winter, we used to be forced to release 500 CFS over the dam because of some management issues. But now with our recharge program, our goal is to keep it dry, especially in drought years. So there's absolutely no water flowing over here. And so in the state water plan, the theory is that we develop the entire snake above Milner for agricultural use. We get maximum use out of that. And then generally below Milner Dam, we're using the river mostly for environmental purposes. We're using it for aquaculture, and we're using it for hydropower generation. And so this is called the two river doctrine. And there's Swan Falls controversy was a challenge to that. And eventually the state said, yep, we're keeping the 0 flow at Milner as our target. And so why is that the target? Because as you go down from Milner in the canyon, you have all these springs coming out of the canyon walls, and there's just miles of these springs. And so the flow, by the time you get to King Hill, 70 miles downstream, the flow in the river is back up to 5,000 CFS or more. And it's all coming in from the aquifer. And this aquifer water is very clean. It's been filtered through the aquifer system. So it's clean, it's cold, and that's why it's used for aquaculture and raising trout. And in this case, this is me down in one of the canals coming out of the, that's pulling some water. This is at the state fish hatchery out of these springs. And this is a sturgeon that decided to come along and interfere with my water measurement. He kept bumping into me, and it was pretty entertaining. But yeah, if you've never been down in that portion of the canyon and seen those springs, it's really spectacular. And so this is kind of the second Snake River formed by the discharge of the aquifer downstream. And so if you look at this map, this is again from Google Earth. Milner's down here somewhere. I can't quite see it on my screen. And then you're diverting water up here, up to the Big Wood, which is off the screen. And then this is the North Side Canal Company. And this is the Twin Falls Canal Company. So from Milner, where the flow is 0, to just at the edge of our screen, actually just off the screen, is King Hill. The river is fully recovered back up to a flow of around 5,000 CFS. And that's kind of the two river system. So one of the big challenges we have in the state, and unfortunately on this computer, the screen, the colors didn't come out, but right here is the wintertime minimum stream flow at 5,600 CFS. And that goes until March, when at the end of March, when most of the water rights kick in. And then the minimum stream flow, and this is at Swan Falls Dam, by the way, which is just south of here on the Snake River. And then it drops down to 3,900. And so if you remember your Idaho history, there was this big Swan Falls controversy in the 1980s. And it established this minimum stream flow right for Idaho Power for hydropower use to solidify this two river system. And so this is a forecast we produced of what that discharge was going to be this year. In our really hot June and July, the hottest on record, kind of caused us to dip below what we were expecting. But the 3,900 level that we need to keep as a minimum stream flow is right here. And if that aquifer continues to go down, which is the pattern it's on, then eventually we're going to start hitting this minimum stream flow, and then we'll have to curtail certain water rights upstream. And so when you curtail a water right, you cut it off. That person is done irrigating. And for a curtailment of groundwater, that would probably be for the entire season. So they would get a notice, and we've sent these out a number of times. Usually people come up with solutions to resolve it, but we've sent these notices out and told people you're not going to be able to irrigate this year. And that's devastating if farming's your business. And so usually there's some kind of solution that's derived, and maybe they rent some storage water and, send it to whoever needs it, or they come up with some solution based off whatever the water resources are available here. We have no idea how this controversy would be resolved if we hit the minimum. There's discussions going on about what to do, but that's one of the major challenges we face. And of course, with climate change added in there, you could have a little bit higher crop water demand, which pushes you down even closer to that 3,900. You also potentially have more water use above Milner Dam from both groundwater and surface water. And if people continue to conserve water and turn it into crop yield, which of course farmers are motivated to do, and consume more water upstream and less recharge to the aquifer, then this value continues to, this whole hydrograph just shifts downward. And so in order to combat the decline of the aquifer, what we do, this is the Milner Gooding Canal, and I think this is milepost 31. Yeah, it is. This is the milepost 31 discharge. And I came out here and we did some measurements to try to figure out what kind of instrumentation we could put in here to get the best measurement. And when this thing is going, it's loud. There's just a rush of water. And when they opened it up the first time and began to fill up this lake, this is sitting over top of the aquifer, and they would actually see whirlpools develop, just like in your bathtub when you pull the plug, and water is just going down into the aquifer. Eventually, those kind of fill up with a little bit of sediment, and so it's now more of a gradual seepage. But this rate, I think on this day, was about 500 CFS, which is about the Boise River in wintertime, just going right down into the aquifer. And eventually it starts out, builds up a lake, and eventually that lake hits a point where everything is stable. You just got the 500 coming in and the 500 going down. And they sent us out one day, and we had to hike this whole thing with GPS to kind of outline what the extent was at the given flow rate, and then we can monitor that over time to see if sedimentation is creating any kind of issues. But so that, yeah, the state just in the wintertime, to get Milner down to 0, we want to put water here, and that water, once it gets into the aquifer, it's going to gradually travel over to the river over a long period of time. Groundwater travels at the rate of about, in this area, about 300 to 600 feet per day. So that's like a football field or 2 football fields per day. So it's a very slow rate. And so the idea is, if we put this here in the winter, it'll build up the discharge from the aquifer for years down in the canyon. And so you'll get more and more water coming into the canyon by diverting here in the wintertime. And then the other thing that the state is doing is we do cloud seeding. So this right here is an airplane, and these are flares, silver iodide flares. You light this up and it looks kind of like a sparkler, and the plane just flies right into the winter storms as they're coming, releases the silver iodide, because for precipitation to fall, you have to have some kind of small dust particle, or in this case, silver iodide particle, that the water can condense around. So the more particles you get out there, if the storm conditions are right, the more snow you can develop. And so there was this big program with Idaho Power and a number of governmental agencies and universities. They did this huge research project called Snowy. And this is a radar that they put up on top of one of the mountains on the back of a truck, and they would track the flights of the airplanes, and they would see the cloud formation behind it. And they got a number of articles published in Nature, which is one of the top research journals in the United States, or in the world, actually. And so they really proved that you can add snow, get more snow out of a storm by seeding it. And so right now, Idaho's got a massive program to expand cloud seeding all across the state. And we're considered to have one of the most advanced cloud seeding programs in the country right now. We were down in Utah, and everybody down there was envious of our cloud seeding program. So we're coordinating with them, and hopefully this year we'll start cloud seeding the Bear Basin, which is a basin we share with Utah and southeastern Idaho. And so if we look at climate change and what that does to the hydrograph, going back to the hydrograph, this is our typical hydrograph. And so you'll notice the water demand kicks in here on the orange line. And this is just happened to be the way it worked this year, just as the snow is melting. And so what happens if you shift the hydrograph back 2 weeks, now this water is starting to run out of the mountains 2 weeks early before you have the water demand. So now that water, if the reservoir system is full, which it looks like it fills in this illustration on February 1st, it actually doesn't. There's flood control operations going on, but this is just a simplified illustration. Then that water becomes available for recharge. And in this case, it would be available for recharge because you have enough water to fill the reservoir system. But then because you've shifted the hydrograph, you start cutting the natural flow rights that we discussed earlier down, and people have to start calling for storage water. And if you look at the volume, in a hydrograph, the area under the curve is a volume because you've got a rate over a time. So you take that rate and you put it over time and you end up with a volume. And so if you look at the difference between those two, there's a lot more water being pulled out. And if you look at the reservoir simulation here, the pre-cloud seeding is the dark blue, and the light blue represent, or sorry, not cloud seeding, climate change is the dark blue. The current climate is the dark blue, and the light blue is with climate change. And so each year you end up with, more of a dip into your reservoir. And the concern is that over time, and I've simulated this through an Excel sheet, which would be an interesting illustration to do with a group. It's just a little clunky, but you can see that in multi-year droughts, we end up running out of reservoir storage earlier under climate change. And so the challenge becomes, then how do we fight against that? Well, we can build more dams, but that's really hard to do. There's plenty of room to store more water. But if we can recharge the aquifer, then we get that water coming at a steady rate, slowly over, over years of time. And so the thought is to try to, kind of restore and rebuild the aquifer. And of course, the state's looking at more dam opportunities to build dams, but we'll see if that ever happens. That's pretty skeptical to pull that off with all the environmental issues that accompany building a dam. But with that kind of wraps up the presentation. Do we have any things we'd like to discuss?
Yeah, I saw a number of questions coming into the chat. We'll start with the cloud seeding ones because there's a few questions on that. Kayla's wondering if the potential impact of cloud seeding on water levels has been projected yet.
We're right in the middle of doing that project. We've looked at it a little bit at small scales. At the small scale, basically cloud seeding in a drought year, most of that water is going to go to farmers. When you have wetter years, a lot of that water goes to hydropower generation and recharge. But as far as quantifying it out, we've got some really rough numbers that I'd probably get in trouble if I threw out. Because if people get those rough numbers, they'll become the gospel here pretty quick. So we're in the middle of a big project to model all the reservoirs with the aquifer and go back for a period of time. And we're right now building that model out to look at how cloud seeding will impact the aquifer and the timing of water availability across the state.
Great. The other question we have about cloud seeding is how much do we know about the negatives of cloud seeding?
Well, right now, they've done a fair amount of research. I've been told. I haven't done it myself, but I've been told they've done a fair amount of research into silver iodide, and it doesn't seem to be an issue. But Idaho Power is currently looking at another technique where it just releases they burn off propane at really intense heat as they go through a cloud system, and it burns off all the gas because it's at a super high heat. But somehow, and I don't know the exact science behind it, but it causes the dust particles that are already in the atmosphere to be able to pull on more moisture to those particles. And that way you could just, send this basically fire through the clouds when you have a snowstorm, increase the amount of snow collecting on the existing dust. And then, once the temperature cools down, back down, which it does pretty rapidly, then those little particles can no longer hold that additional water and it falls out as snow. So that would be a big step forward, because then, it gets rid of the whole silver iodide issue. You just have dust falling out like it normally does.
That's interesting. I saw in the chat someone saying they had no idea Idaho was on the cutting edge of this, and I only knew because of previous meetings with you. So it's really interesting. Dylan was asking, and this is, I believe, in reference to you had said that adding dams could potentially increase the recharge. And Dylan wants to know what would happen if we removed some of the dams.
Well, if we remove some of the dams, it depends on what kind of dam. If you remove a hydropower dam, which is typically run of the river, it's just passing flow, you just lose hydropower generation, which this year there are some claims that those lower Snake River dams were critical to stabilizing the power grid during the heat dome. So, you have to look at the entire system. We've got to have a good, stable supply of electricity to offset the removal of hydropower. But if you removed an irrigation dam, you're taking away somebody's water supply. And so that becomes quite a challenge too. But we've got some pretty old dams across the state, and they're doing work to try to, test them and make sure they're holding up. But I would suspect before they actually tore one down, they'd probably just replace it. And they've done that across the country where they put a dam downstream, and they looked at this for Arrow Rock, not because it has structural problems, but because they were considering raising it. But you just build a dam in front of Arrow Rock and just flood Arrow Rock, and now you've got a new dam, and with possibility to store more water. But yeah, removing any irrigation dam would be, you'd have to buy out, the property and get an agreement. But we've done that in the state when it comes to people pumping out of the Snake River. There was this big project called the Bell Rapids Project. And the Idaho Water Resource Board was able to come along and buy up that whole project, all the water rights on it, and just let the land go dry. And then they had extra water in the Snake for environmental purposes, mainly the flow augmentation for the salmon.
There's actually a question floating around here. I wonder if this is John from Alaska, John, that I know, but he's asking, does proposed dam removal for salmon on the Columbia River have any impact on the overall water availability?
Not that I can see, because those are all hydropower and they're out of state. So it becomes more of a power grid issue than an irrigation issue. There's no irrigation water, at least for Idaho, being stored behind those dams that I'm aware of.
And then I wanted to make sure we got to, there was a question about salmon earlier. Danny wanted to know about the zero flow at Milner and what that means for fish passage, which, great question.
Well, with Shoshone Falls, which is just downstream, there was never salmon above that zone. And down below it, there's an area called Salmon Falls Dam. Well, there's the lower Salmon Falls and the upper Salmon Falls Dam. There's 3 Salmon Falls dams, which gets a little confusing. One is on Salmon Falls Creek and 2 are on the Snake River. But the 2 on the Snake River, that was kind of the upper limit of where salmon traditionally came up the Snake River. And then they got stuck at Shoshone. They couldn't get beyond Shoshone Falls. So from a fish passage perspective, there's only a very small stretch from Milner to Shoshone. So there's really not much issue there from a fish passage perspective.
All right, and then I've got Cindy and Elizabeth have similar questions here. Basically, is aquifer recharge being done elsewhere in the state besides the Snake River? And,
yeah.
Oh, and then a continuation, are there other entities who might contribute to aquifer storage?
Yeah, there's the state-run aquifer recharge program, and then there's a number of private recharge programs run either by irrigation districts or canal companies. Where I do a lot of work on the Big Lost River, up above INL, and up there the Big Lost River Irrigation District runs a recharge program anytime they have any excess water in the system. And mainly it's just to hold water up higher in their alluvial aquifer so that they can utilize it out of the aquifer rather than have it run out into the Snake Plain and sink into the East Snake Plain aquifer. When you look at volume, it doesn't really impact the East Snake Plain aquifer. It's just holding the water up higher where they have access to it in drought.
All right, and I think we have time for one more question. It's got the word doomsday in it, so it should be an exciting one. Meredith from the city of McCall asks, members of the community are concerned that the city of McCall is a junior water rights holder at the Payette watershed, and the senior right holders are farms in Payette and Fruitland. And is there a doomsday scenario where a municipality would have to give up water rights to sustain the senior rights downstream?
Well, according to the Idaho Constitution, domestic water use has the highest priority, and it trumps any kind of downstream irrigation, hydropower, mining right. Actually, Idaho's water rights weren't established initially for irrigation. They were initially established for mining. Of course, now they're mainly used for irrigation, but the whole concept of prior appropriation was developed for mining. But yeah, in the order of priority, domestic is always first, but not your lawn, your drinking water. Your lawn can go. It falls in the irrigation list.
I wonder too if maybe a thought that we can end on is how this system that we've set up with prior appropriation and the water rights, how that translates into maybe how we view water at some of our sites as we move forward. So great answers. Thank you for whetting our appetite, if you will, for this series on climate change and water scarcity in Idaho.
Oh, you went on mute.
Oh, I appreciate it. And maybe if we can give a little round of applause. Thank you so much for sharing your expertise with us.
Yeah, it's great to be with you all.
And before we wrap up for the evening, I wanted to touch base on what the rest of our series looks like going forward. Next week, November 4th, on Thursday at the same time, we have Dr. John Abatsoglu from the University of California. He's interested in the hows and whys of climate and weather, and also the so whats. And specifically, one of his so whats is going to be that knowing these trends are going to affect things like our agriculture, what are farmers doing to adapt their agriculture to these trends? So a good place to continue our discussion. After that, we're going to have the climate change coordinator of the Nez Perce tribe, Stephanie Krantz, and she's going to talk about different ways to view water. So we've kind of touched on prior appropriation. She's going to touch on other ways to view and value water out west. And then finally, we're going to have Dr. Sarah Ray, who is a professor of environmental studies, and she's going to be doing our pedagogy. So she's going to give us tips for teaching and communicating in the community. And she wrote a book that I think the title alone is a really great summary of what she studies, which is A Field Guide to Climate Anxiety, How to Keep Your Cool on a Warming Planet. So that's what the rest of the series looks like. I'm going to drop a link in the chat in case you are not registered. And the last thing that we have for you is we would love if you could take a survey for us to help us figure out what it is that you're talking about at your sites. So I'm going to put that in the chat, and I'll send out an email with this recorded if you want to pass it along to anyone else, and the link will be there as well. Let me find my chat. And I'd also like to thank the regional ETS team for joining us as well today. So there we go. There's the, almost, there we go. There's the link to that survey. And you'll also notice at the end, there's an additional survey if you would like to be a part of a workshop that we would like to do coming up in the spring. So if you are local and interested in engaging with us more and building our community of practice, we would love to have you at that workshop as well. So that's what I have. ETS members, anything to add? All right.
I just wanted to thank David for doing this. I really appreciate his time and presentation, and it's so great to hear from regional professionals and experts on the topic. So thank you, David.
You're welcome.
Fun to see exciting solutions too, David. Okay.
All right. Well, we hope to see you next time, and I'll be sending that follow-up email soon. So thank you all.
Bye.